here is a second order polynomial function, okay? And that's why it is a curve, because second order polynomial function is not a straight line, okay? So coming back to here, okay, we are going to prove. So let's see what this diagram is all about, okay? So what we have over here, the shaded region, okay, shaded region A is the area of interest, okay? So the area of interest is controlled by what? By y, okay? So y over here is your variable. And y starts from the geometric centroid. Okay, y starts from geometric centroid. And when that is the case, right, so this is our geometric centroid. Okay, that is our geometric centroid. So basically, okay, basically over here, this line, the geometric centroid, this is our datum. Okay, so this geometric centroid is our datum. So i.e. at the geometric centroid, y is equal to what? 0. Okay, and when it's going upwards, all right, it can be positive. It is positive. When it's going downwards, it is negative. Okay, so now going upwards is positive. You can flip it around later on once you're comfortable with the expressions, and entirely up to you. Okay, now y bar, okay, y bar over here is the centroid for the area of interest. Okay, so that's why it's at C prime over here, and in the shaded region, as you can see in this shaded region, right, the distance from the top and the distance from the bottom of the shaded region, the distance are the same. Okay, so that is the centroid. Okay, now I'm now going to copy this entire diagram. Okay, I'm going to copy this entire. We're going to bring it over. Okay, so the equation that we are going to use is shear xy is equal to Vy over Izz Qz over T. Now, over the time, I've done so many of these questions that I have derived, or I came up with rules, okay, due to the mathematical derivation. Okay, and let me be very clear. This is one of the most difficult topic in structure analysis. Okay, I'll tell you this outright. The level of analysis is very intense. Okay, more worse than buckling, worse than bending moment, worse than Mohs circle. Okay, so say it's the toughest topic. Okay, but I've come up with rules so that it's simple for you. Okay, So the first rule is this, okay? Rule number one. As long you always apply to this rule, okay, you will be fine. Okay, and these rules cannot be broken. And when it can be broken, I'll tell you. Okay, so rule number one is that V and I are constant and independent on the size of the area of interest. Okay, so first thing that we learn, okay, that you know now, is Vy is constant and Izz is also a what? Is also a constant, regardless of the area of interest. Okay, if the area of interest grow bigger, still the same. Vy is a constant, Izz is a constant. Okay, so now first we do something regarding, so Vy, yep, Vy is basically the shear force coming down in the vertical direction. Next, we are going to calculate Izz, right? So we know that from here to here, this is our width. And from here to here, this is our depth. Because the axis of interest is our what? Our ZZ axis. Okay. So the width is equal to B. The depth is equal to 2C cubed divided by what? Divided by 12. Okay. So we expand the term in the bracket. So B multiplied by 8C cubed over 12. So we will have 2 over 3 BC cubed. Okay, we have 2 over 3 BC cubed. Now, the next thing that we're going to have is we are now going to find what is our QZ. Our QZ is equal to A Y bar, as you can see, right? Like what I showed you before. So the area, what I like to do with the area, I like to go to width, depth, Y bar. Okay, I like to go to width, depth, Y bar. So QZ now, we know the width is equal to B. The depth, right? The Y D Y bar. Now the area, right? What we can see over here, right? What we can see over here is the area is changing. Okay, the area is changing is because the Y is the variable, right? So the depth is equal to C minus Y, right? Because C minus Y is basically this distance over here. So this is your C minus Y, okay? And then C minus Y, and then over the Y bar is C plus Y multiplied by half, okay? So this term over here is your width. This term over here is your depth. This term over here is your Y bar. Now, some of you will ask me, Eugene, why is the Y bar C plus Y multiplied by half? Okay, so now the best way, so we know that this distance over here, right? We know that Y bar is equal to C plus Y multiplied by what? Multiplied by what? Half. And some, if you can remember, or you want to prove yourself why, let me ask you a very simple question. Okay, if this is 3, right, and at the top is 9, okay, at the top over here, at this point over here, right, this is 9, and at this point over here is 3. What is C prime, or what is our Y bar? You will say it's 6, yes or no? So how do we get 6? Because our C is 9, our Y is plus 3, multiplied by half, this is equal to what? 6. Very clear. Don't memorize, okay? Do things like this to help to ease your life, okay? So from here, that is how we get this expression over here, okay? So then we will do B. C multiplied by C is C squared. C multiplied by CY, minus by CY, minus, okay, disappear. Minus by Y squared multiplied by half. So in terms, this will be equal to B over 2, C squared minus by Y squared. Okay, you can see that now. So the next thing that we have now, okay, and the next thing we have now, before I go any further, based on what we have derived, okay, the depth is C minus Y, and the Y bar is C plus Y, rule number 2. Okay, rule number 2 states the analysis starts from the distance furthest away okay, from the central. Okay, from the geometric centroid. Okay, so what it means, right? This over here, okay, I will use a different color. This over here is the analysis direction. It starts from where? This point over here, it starts from Y max, okay, where you have your maximum what? Y, and then it moves towards the centroid. Okay. And then, so that is our rule number 2. Rule number 3, which we have written down, not I'll show you before. Rule number 3, the datum is at the centroid. Okay. And then rule number 4 is that the positive, okay, the positive first moment of area cannot cross the centroid. Okay, so rule number 4, right? The first moment of area over here, right? It cannot cross the geometric centroid. So the y0 is here, okay? So the positive bending moment, the positive first moment of area, okay, is at the top. The negative first moment of area is at the what? Is at the bottom. Okay. Now the next thing that we're going to have, okay, so we have 4 rules already. The 5th rule is that the shear flow Q, okay, can only flow in one direction. okay, in one direction. So IE, right? I'm going to, I know it's a bit of a mess. I'm going to copy this diagram again. Let me see if I paste what happened.